For part B, we are going to be exploring different types of disjoint set implementations. So first we have a quick find data structure. So if you recall what quick find is, let me actually go to a mini lecture. So this is going to be found under lab mini lectures and then lab 20 disjoint sets. Okay, so let me actually just open it up. So the lab went through two different implementations, and the second one was expounded upon further using some optimization. But the first implementation is quick find. So the idea here is that we want the find operation to be quick, really quick. And so we use an array. Okay, so the indices are going to represent the vertices in our entire disjoint sets data structure. And then the value at an index is going to be the set that that vertex belongs to. And I shouldn't say vertex because it's not really a graph in this implementation. It's really just sets of items. And then the runtime analysis, we say that the worst case find is going to be theta 1. It's constant because all we really have to do is just access a value at an index, right? We know what the index is because find is going to take in that index. It's going to take in the item. And then the worst case union is going to be linear because in the worst case, we have to basically, so how union works for quick find is that if you're unioning, let's say 0 and 3, right? Then you need to find the value at these indices. And if they're different, then you need to change one of their values to be the exact same as the other. So for example, 0 has set 0, set value 0, 3 has set value 3, so they're different, so we can union them. And what happens is we change one of either 3's set to be all 0's, or we change 0's set to be all 3's. Okay, so in this case, it's a little bit simpler to change the 3's to be 0. So 3 is now going to have, index 3 is now going to have 0, index 4 is also going to have 0. But that's basically how union works. And so this will help you with this part of the question. So if you want to perform a union of 0, 6, let's first actually write out the array for this. So at index 0, so basically item 0 is going to be in the set 0, okay? And then 1 and 2 are having 0 as their parent, and so they're going to belong in the same set. 3 is going to be its set number, right? Because it's the root of the entire data structure, of the entire set. And so whatever the root is, that's going to be the value of the set, okay? 4, 5, and 6 are pointing to 3. In this case, the pointers are kind of in reverse. The parent is pointing to the child. I like to have it in the opposite direction, the child pointing to the parent, but either way works, same idea. And so all of these is going to be 3's. Okay, so now after we do this union, okay, so first what happens, we need to find the set value of 0 and 6. So 0's set value is 0 itself. 6's set value is 3. They're different, and so we're good, we can union. And when we're unioning, we want to change one of these values to be the other one, right? And so one thing that we can do is we can have all the 3's become 0, just like how we did in the example before. So we could potentially have 0, 0, 0, 0, 0, 0, 0, all zeros. This is kind of a less efficient implementation because it would have been quicker to change the 0's to 3's, right? Because we only have 3 zeros, whereas we have 4 3's. But this is arbitrary, right? If we have a tie, we break it arbitrarily. Okay, and so how does this look like as a tree? Well, everything belongs to one set, right? So that means that we have a 0 as the root of our entire set, and then everything points to 0 directly. So we have 1, I'm doing the pointers in reverse direction of the solution, and 6. Okay, so everything is just one level because everything is directly pointing to the root, right, based on this array. Okay, so that was part 1. And now part 2, actually I'll do this in another video.